All right, guys, welcome back to Tabular AP free response questions, where we do calculus with numbers from tables. We'll be estimating slope and also estimating area, stuff like that. What we'll be working with today is the questions that lie in Domain 2. And Domain 2 is all about knowing how to use a definite integral to express information about accumulation, and also using a definite integral to express and find information about the average value. Now, in order to handle this last part, this is going to be important for us in this problem right here. We need to know that the average value of a function is equal to 1 over b minus a times the integral from a to b of f of x. That's what we'll be using in the average value problems. So let's take a look at this question. So this is Joanna jogging along a path again. You can see that she's got velocity in the y and time up here in the x part of the table. And then what we're going to take a look at here is 2015 part D. So part D is based on the model from part C. So let's take a look at part C. Part C says Bob is riding his bicycle along the same path. Bob's velocity, okay, is modeled by this function. So this function right here is Bob's velocity. T is measured in minutes and B is measured in meters per minute. Okay, so in part D, we need to use that function B and find Bob's average velocity during the interval 0 to 10. Okay, so this is a pretty simple setup. Really what we're going to do is just use this average value equation and set up an integral. So the average velocity is going to be equal to 1 over 10 minus 0, the integral from 0 to 10, of this function b of t, which is t cubed minus 6t squared plus 300 dt. The reason why this makes sense is because this particular integral right here, that represents like the distance that Bob traveled from 0 to 10, or the displacement. And then this fraction right here represents the time span. So really what we're doing here is doing distance divided by time, which is getting us this average velocity all over again. All right, so let's take a look and let's calculate this. So this would be equal to 1/10. And then in order to calculate this integral right here, because this is a no calculator problem, what we're going to do is anti-derive and plug in the points. Do the fundamental theorem of calculus. So let's anti-derive. That would be 1/4 t to the 4th minus, and then 3, excuse me, that is not correct, 2t cubed plus 300t. We're going from 0 to 10. Okay, and then this would be equal to the 1/10 again. And I'm going to plug in 10 into each of these, so that would be 1/4, 10 to the 4th, minus 2, 10 to the 3rd, plus 300 times 10. And then, technically speaking, I would also plug in 0, but that doesn't really change anything. So I can put it there, I can leave it, doesn't really matter. And then because this is an AP problem, we don't need to simplify at all, so that would end up being our average velocity, which if you did want to calculate that, that would be equal to 350 meters per second. Anyway, but you don't have to do that. All right, so take a look at the next few problems from this subpath, and remember, if you need to check your answer, and you should be checking your answers too, just type in the year of the question, and then the word solutions after it, like AP Calculus 2015 solutions, and then that should bring you to the scoring rubric where you can check your answers. And feel free to ask me any questions too. Okay, so let's take a look at another question from the next group of this subpath, and this is going to be the last group for this particular domain. They all sort of adhere to this pattern of finding accumulation or finding average value or something along those lines. So what we've got here is 2016C. We see that water is being pumped into a tank at a rate, rate modeled by this in liters per hour. And water is removed from the tank at a rate modeled by R of T, right here, where R is differentiable and decreasing. Okay, a lot of information in this problem. Selected values of R of T are shown in the table above, and at time 0, there's 50,000 liters of water in the tank. So let's take a look at part C. Remember that in this domain 2, what we'll be doing is solving problems related to accumulation or average value. So be looking for those particular patterns. So in part C, it says use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. Okay. So what I did is I went ahead and found what our answer to part B would have been, 8,050. And then this answer means the total amount of water removed from the tank. So this is water removed over 8 hours. So in order to answer part C, we really want to put together multiple pieces of information. We want to find the total amount of water in the tank, and what that's going to involve is it's going to involve finding the amount of water that has been added into the tank, and that will be an accumulation of water from 0 to 8, and then of our rate in, which was W of T, which is given up here. We need that piece of information. We also need the piece of information that tells us how much water was removed from the tank, and that is this approximation right here, the 8,050. And then we need one more piece of information as well. The amount of water in the tank was 50,000 liters to start with. So we're going to add that all in front. And then we add in the water that was added in, and we subtract out the water that was subtracted. So let's take a look at what this would end up equaling. 50,000 will, of course, be 50,000 plus. And then in order to calculate this integral right here, we've got a function model for that given right there. And this is a graphing calculator problem. So what we're going to do is just reach for our calculator, and we're going to math 9 it. Okay, I'm going to give you a little bit to math 9 it. In the end, what we should get is 7,836.1953. Remember to include, I usually like to do 4 decimal places because they need to be correct to at least 3. And then we're going to subtract out the amount of water that was removed over the 8 hours, which should be your answer from part B. And then let's combine all of these pieces together. So 50,000 plus 7,836.1953, and then minus 8,050. And we will get 49,786. And then, to the nearest liter. Okay, so we just need to end with that. Liters of water in the tank. Okay, that should feel a lot like a rate in, rate out problem because it basically was, but it used some tabular piece of information from the table above. We began with the initial amount, 50,000. We added in the amount that came in, and we subtracted out the amount that went out. And that gave us our total in the end. Okay, again, go ahead and try the other ones, and if you got questions, feel free and find me or send me an email. And remember to check your answers as well with the solutions on the internet. Okay, thanks guys, bye.